Our team is working hard to keep the content up to date. If you find this video helpful, please let us know in the comment. We really appreciate if you like and subscribe to our channel. If you are looking for any particular certification which is currently not available on our channel, please mention that in the comment. Our team will prioritize those. Thank you. Next question is: a consulting company was hired to assess security vulnerabilities within a client company's application and propose a plan to remediate all identified issues. The architecture is identified as follows: Amazon S3 storage for content, an auto-scaling group of Amazon EC2 instances behind an elastic load balancer with attached Amazon EBS storage, and an Amazon RDS MySQL database. There are also several AWS Lambda functions that communicate directly with the RDS database using connection string statements in the code. The consultants identified the top security threat as follows: the application is not meeting its requirement to have encryption at rest. What solution will address this issue with the least operational overhead and will provide monitoring for potential future violations? A. Enable SSE encryption on the S3 buckets and RDS database. Enable OS-based encryption of data on EBS volumes. Configure Amazon Inspector agents on EC2 instances to report on insecure encryption ciphers. Set up AWS config rules to periodically check for non-encrypted S3 objects. B. Configure the application to encrypt each file prior to storing on Amazon S3. Enable OS-based encryption of data on EBS volumes. Encrypt data on write to RDS. Run cron jobs on each instance to check for unencrypted data and notify via Amazon SNS. Use S3 events to call an AWS Lambda function and verify if the file is encrypted. C. Enable Secure Sockets Layer (SSL) on the load balancer. Ensure that AWS Lambda is using SSL to communicate to the RDS database, and enable S3 encryption. Configure the application to force SSL for incoming connections and configure RDS to only grant access if the session is encrypted. Configure Amazon Inspector agents on EC2 instances to report on insecure encryption ciphers. D. Enable SSE encryption on the S3 buckets, EBS volumes, and the RDS database. Store RDS credentials in EC2 parameter store. Enable a policy on the S3 bucket to deny unencrypted puts. Set up AWS config rules to periodically check for non-encrypted S3 objects and EBS volumes, and to ensure that RDS storage is encrypted. Correct answer is C. Next question is: a new zero-day vulnerability was found in OpenSSL requiring the immediate patching of a production web fleet running on Amazon Linux. Currently, OS updates are performed manually on a monthly basis and deployed using updates to the production auto-scaling group's launch configuration. Which method should a DevOps engineer use to update packages in place without downtime? A. Use AWS code pipeline and AWS code build to generate new copies of these packages, and update the auto-scaling group's launch configuration. B. Use AWS Inspector to run yum upgrade on all running production instances, and manually update the AMI for the next maintenance window. C. Use Amazon EC2 run command to issue a package update command to all running production instances, and update the AMI for future deployments. D. Define a new AWS OpsWorks layer to match the running production instances, and use a recipe to issue a package update command to all running production instances. Correct answer is C. Next question is: a company runs a production application workload in a single AWS account that uses Amazon Route 53, AWS Elastic Beanstalk, and Amazon RDS. In the event of a security incident, the security team wants the application workload to fail over to a new AWS account. The security team also wants to block all access to the original account immediately, with no access to any AWS resources in the original AWS account, during forensic analysis. What is the most cost-effective way to prepare to fail over to the second account prior to a security incident? A. Migrate the Amazon Route 53 configuration to a dedicated AWS account. Mirror the Elastic Beanstalk configuration in a different account. Enable RDS database read replicas in a different account. B. Migrate the Amazon Route 53 configuration to a dedicated AWS account. Save/copy the Elastic Beanstalk configuration files in a different AWS account. Copy snapshots of the RDS database to a different account. C. Save/copy the Amazon Route 53 configurations for use in a different AWS account after an incident. Save/copy Elastic Beanstalk configuration files to a different account. Enable the RDS database read replica in a different account. D. Save/copy the Amazon Route 53 configurations for use in a different AWS account after an incident. Mirror the configuration of Elastic Beanstalk in a different account. Copy snapshots of the RDS database to a different account. Correct answer is A.